Have you ever wondered how scientists can tell if a population is changing genetically, even before observable traits shift dramatically? Deviation from Hardy-Weinberg Equilibrium indicates that a population is evolving, meaning its genetic makeup is actively changing due to one or more evolutionary forces. The Hardy-Weinberg principle acts as a crucial baseline or null hypothesis in population genetics, describing a hypothetical population that is not evolving. This theoretical state requires 5 strict conditions to be met. There must be no new mutations, no gene flow or migration in or out of the population, a very large population size to prevent random genetic drift, completely random mating among individuals, and no natural selection favoring certain traits over others. If a real population's observed allele and genotype frequencies significantly differ from what this principle predicts, it signals that at least one of these evolutionary mechanisms is at work, altering the genetic landscape. To detect such a deviation, researchers first calculate the expected genotype frequencies using the Hardy-Weinberg equations, based on the observed allele frequencies within a population. Then, they compare these expected frequencies with the actual observed genotype frequencies through statistical tests. A statistically significant difference between the observed and expected values confirms that the population is not in Hardy-Weinberg equilibrium, prompting further investigation into which specific evolutionary factor or combination of factors is driving the change. Understanding these deviations is truly foundational for evolutionary biologists, acting like a diagnostic tool. It allows them to pinpoint the specific mechanisms of evolution affecting a species, from the subtle effects of genetic drift in small isolated groups to the powerful sculpting hand of natural selection in response to environmental pressures. It is the scientific method in action, where the null hypothesis of no evolution is challenged by empirical data. Recognizing when a population deviates from Hardy-Weinberg equilibrium provides invaluable insights into the dynamic processes that shape life on Earth, helping us understand how species adapt, diversify, and sometimes even face threats to their survival. It helps us trace the ongoing story of evolution, one genetic generation at a time.